Dear students, what I want to share with you today is the topic alcohols. Myself, Dr. Digna Varghese. Alcohols. We know alcohol is an organic compound. Alcohols are corresponds to the general formula is ROH, where R is an alkyl group or substituted alkyl group here. If the alkyl group is saturated, the homologous series of alcohols will be represented by the general formula that is CnH2n plus 1 OH. If n is equal to 1, it is methanol. If n is equal to 2, it is ethanol. If n is equal to 3, it is propanol. If n is equal to 4, it is butanol, and so on. Classification of alcohols. Here we are discussing the depending upon the carbon atom carrying the OH group, the alcohol is classified into primary alcohols. Here you can see the primary carbon atom attached to the OH group. Second one is secondary alcohols. Here you can see the secondary carbon atom attached to the OH group. Third one is tertiary alcohols. The tertiary carbon atom attached to the OH group. So, depending upon the carbon atom carrying the OH group, it is classified into primary, secondary, and tertiary alcohols. Another way of classification is the depending upon the number of OH group present in a given alcohol. First one is monohydric alcohols. That is, you can see the CH3CH2OH. Here only one hydroxyl group is present, so it is a monohydric alcohols. Dihydric alcohols. Here you can see the number of OH group is 2, so it is a dihydric alcohol. Third one is trihydric alcohols. Here you can see 3 OH group is present, so it is a trihydric alcohols. Monohydric alcohols are also classified into primary, secondary or tertiary alcohols. So compounds containing 2 OH groups are called dihydric alcohols. One OH group is known as monohydric alcohols and 3 OH group is known as trihydric alcohols and so on. Preparation of alcohols. Here you can see preparation of alcohols from Grignard reagent. Here you can see a carbonyl group, the nucleophilic addition of Grignard reagent to a carbonyl group. Here you can see a carbonyl compound which is reacts with a Grignard reagent, that is the general formula is RMgX. Grignard reagents are nothing but that is alkyl magnesium halides. So the Grignard reagent attached to the carbonyl group, whether it is a aldehyde or a ketone, it forms an adduct here, that is COMgX. Here you can see the mechanism is that oxygen is the most electronegative element compared to carbon. So the electrons are shifted towards oxygen. So it becomes positive charge and here negative charge. Okay, we know a metal is a Lewis acid. So it has a get a delta plus charge here and here you can see compared to metal the electrons are shifted to alkyl part, so it is a partial negative charge. So here it's a nucleophilic addition reaction. The negative part attached to the positive charge of the carbonyl group, carbon of the carbonyl group, and it forms an adduct here. Here minus charge, it has a plus charge. Okay. And followed by acid hydrolysis. Here you can see the product is an alcohol. In water, it will undergo splitting like this H, OH part. So here forms alcohols. Next one is magnesium hydroxyl halide is formed. So preparation of alcohols is that a carbonyl compound which reacts with a Grignard reagent undergo nucleophilic addition reaction to form an adduct first, which undergo acid hydrolysis to give alcohols. So here you can see a formaldehyde. The type of alcohol produced depends on whether the starting carbonyl compounds is formaldehyde or any other aldehyde or a ketone. Here you can see formaldehyde, that is its molecular formula is HCHO, which will react with alkyl magnesium halide and forms an adduct here. That is, we know the electron is shifted to oxygen. Here the positive charge. So the negative part of the alkyl halide attached to this alkyl magnesium halide part is attached to this carbon, and the magnesium is attached to the oxygen part. So here you can see O negative magnesium plus adduct forms here, which undergo acid hydrolysis and forming alcohol and MgOH. So we get primary alcohol here. So when we are using formaldehyde with the alkyl halide, magnesium halide, it will give primary alcohol. Here you can see another reaction, that is formaldehyde reacts with the N-propyl magnesium bromide. It is negative, this positive charge, and it will get a negative part here. It's a positive part. So the negative attached to the positive carbonate carbon and forms an addition product here or adduct. It will undergo acid hydrolysis. We will get butanol. Here 4 carbon atoms. So we will get butanol. That is a primary alcohol. So you can see here when formaldehyde used with alkyl magnesium halide, we will get primary alcohol. Here you can see an aldehyde other than formaldehyde reacts with alkyl magnesium halide. It forms the same way as that of the formaldehyde. First forms an addition product or adduct which undergo acid hydrolysis to give secondary alcohols. With formaldehyde, you can see the alcohols forms as primary. Other than formaldehyde, here forms a secondary alcohols. The same reaction, nucleophilic addition, the negative part is attached to carbonyl carbon. Oxygen is attached to magnesium, part of the alkyl magnesium halide, and forms an adduct here. This will undergo acid hydrolysis and forms alcohol. Here you can see the secondary carbon atom attached to the OH group. So it forms a secondary alcohol. Here you can see acetaldehyde reacts with methyl magnesium bromide in dry ether. It will first forms an adduct here, which will undergo acid hydrolysis to form 2-propyl alcohol. It's a secondary alcohol. So with formaldehyde, alkyl magnesium halide reacting to form primary halide, primary alcohol. Other than formaldehyde, any aldehyde can reacts with alkyl magnesium halide in dry ether and further undergo acid hydrolysis to give secondary alcohols. Here you can see a ketone reacts with the alkyl magnesium halide in presence of acid. It will give tertiary alcohols. Here you can see acetone reacts with methyl magnesium bromide. The methyl part is attached to positive part of the carbonyl group and the electron is shifted to oxygen. It first forms an adduct here. It will undergo acid hydrolysis. It will forms a tertiary alcohols and magnesium hydroxyl bromide. Okay, so when we are using formaldehyde with alkyl magnesium halide in presence of acid, it will give primary alcohol. When the alkyl magnesium halide reacts with any aldehyde other than formaldehyde, it will form secondary alcohols. Alkyl magnesium halide reacts with a ketone, it will definitely give tertiary alcohols. Manufacture of ethanol from molasses. Ethanol is manufactured from molasses, which is obtained from the sugar industry by the fermentation process. Fermentation is the process of breaking down the complex organic molecules into simpler ones in the presence of biological catalysts known as enzymes. Here you can see molasses is the mother liquor left after obtained by the crystallization of cane sugar. Okay, here you can see the flow diagram. The sugar cane juice obtained from the plant extract, that is undergo crystallization, it will give cane sugar and molasses. Molasses is the mother liquor left after the crystallization of cane sugar juice. It is a 40, it also contains a 40 percentage uncrystallizable cane sugar. Okay, so molasses again diluted with water to get a 10 percentage sugar solution. Into this, yeast is added and it is kept for 303 to 308 Kelvin for 2 to 3 days. In enzyme, in yeast there is an enzyme known as invertase which will brings the hydrolysis of sucrose to glucose and fructose. Okay, and the enzyme cymase present in the yeast that brings about the conversion of both glucose and fructose into ethanol. So there is a two-step reaction occurs. Manufacture of ethanol from molasses. Here you can see sugarcane juice undergo crystallization that will forms cane sugar and molasses. Molasses is the mother liquor left after crystallization process. It will also contain 40% uncrystallizable cane sugar. It will again diluted with water. We will get 10% sugar solution. To this, yeast is added at 303 to 308 Kelvin for 2 to 3 days. The enzyme present in yeast, that is invertase, undergo hydrolysis of or brings about the hydrolysis reaction in sucrose to give glucose and fructose, which will again reacts with the enzyme thymase present in the yeast and forms ethanol. So we will get ethanol from molasses. Here we are discussing three terms, that is the first one is the wash. What is wash? 8 to 10 percentage ethanol is obtained by the fermentation process of carbohydrates. Remember, 8 to 10 percentage ethanol is obtained by fermentation process of carbohydrates, which is known as wash. Second term is what is rectified spirit. Rectified spirit is the spirit obtained by the fractional distillation of wash, gives 95.6% of ethanol solution. Wash means 8 to 10% ethanol, which is undergo fractional distillation to give 95.6% ethanol solution. That is known as rectified spirit. The third term is absolute alcohol. 100% ethanol can be obtained by the distillation of rectified spirit over quicklime, that is calcium oxide, and a few pieces of calcium. Okay, absolute alcohol is that 100% ethanol is obtained from the rectified spirit by distillation over quicklime and a few pieces of calcium. Thank you for your attention.